Hi there, you're watching part one of a two-part series on unit conversions. In part one, we're going to work with the unit cancellation method, sometimes called the unit fraction method of converting units. And in part two, we'll work with the metric system. So take a look at the map on your screen, and you'll see that just about every country in the world is shown in green, but there's a few that are shown in gray. What do you suppose all the countries that are in green have in common? You probably would guess, most people do, that those are the countries that use the metric system, and that's largely true, but the green countries are the countries that have officially adopted the metric system. So there's three countries that aren't in green, right? The United States is in gray, Liberia, right on the tip of Africa, is in gray, and Myanmar in Southeast Asia. Those three countries use the metric system to some degree, but it's not officially adopted. Because of a global economy and global manufacturing, all countries are importing and exporting and designing and manufacturing parts using the metric system, but it's driven more by the economy than by the government. As a technician, you need to be able to do unit conversions largely because of fluid capacities. I've got some automatic transmission fluid shown there. American vehicles are going to give all those capacities in pints or quarts. European vehicles often going to give those in milliliters or liters, and you should be able to navigate those conversions and figure out those equivalencies without any trouble. That's the goal of this lesson. So let's get rolling. So while most things in this course I allow you to do any way that you want as long as they're mathematically sound, this is one topic that I want you to learn the method that I'm going to show you, even though there are other methods of doing unit conversions. And the reason is we're going to use this method for some topics later on in the course. So in order to get credit for the practice problems and the skill checks, make sure that you are doing the same method of conversion that I'm going to show you in this lesson. What that's based on is this. If you take a conversion fact like the one shown, 1 foot is equal to 12 inches, that is certainly true. But you can take those two values and put them in the form of a fraction. You can put the 1 foot over 12 inches, or you can put the 12 inches over 1 foot. But in either case, they form a fraction that's equal to 1. And the reason is, anytime you have the same thing in the top and bottom of a fraction, like 5 over 5, we know that that's equal to 1. Even if I were to put 9 plus 1 over 10, that's still 10 over 10, that's equal to 1. And so even if I put 1 foot over 12 inches, even though they look different, those things are equal, and they're equal to 1. And that gives us a little trick for performing unit conversions. These type of fractions are called unit fractions, and we use them like this. When we multiply some measurement by a unit fraction, it doesn't change the value. The only thing it does is change the units of measure. And that's because units cancel in the same way that factors canceled when we were multiplying fractions. So here's an example of this. Let's convert 15,400 feet to miles. We start out, step one is to take 15,400 feet, the thing that we want to convert, and put it over 1. Now we take our unit conversion, 1 mile is equal to 5,280 feet, and we're going to multiply that fraction, but we want to do it in such a way that the feet cancel diagonally. Since we're starting out with feet on the top of our original measurement, we want to put feet on the bottom of our unit conversion. That means 5,280 feet will go on the bottom, and the 1 mile has to go on the top. That green one right here, this is called our conversion factor. That is our conversion factor, our unit fraction. Now, when we do that, we can cancel the units off, just like when we were multiplying fractions. We can cancel feet out of the top and cancel feet out of the bottom, and that leaves us with units of miles, and that's what we wanted to convert to. Now, you reach for your calculator. We're going to be using calculators in every lesson from here on out. And we multiply across the top but divide off anything on the bottom of these unit fractions. So we're going to take 15,400 times 1 but divide it by 5,280. So we'll take 15,400 times 1, but of course that doesn't change our number. And then since 5,280 is on the bottom, we divide that off, divided by 5,280. And we get an answer of 2.9166. Let's round that to the hundredth, keep 2 decimals, and that means that this is 2.92 miles. And we're done. Now I know what you're thinking. You're thinking, all we did was take 15,400 and divide it by 5,280. Why do we have to write out that process? Because we're going to be doing some much more complicated conversions, and it'll be hard to keep track of what we're doing on the calculator, but this process allows us to keep track of our units really carefully. So even though some of these problems are going to seem easy, make sure that you are writing them out in this way in your practice problems and on your skill checks so that I can give you credit for those. Let's take a look at a couple more. A cooling system in a car has a capacity of 12 liters. How many quarts is this? Well, we know that we need to take 12 liters and put it over 1. That's our first step. And now we want to multiply it by something that will change liters into quarts. So what's that conversion fact? Well, here's a set of standard conversion facts that you will have access to. Within Blackboard, these are going to be on a conversion sheet, just like this one. So you can print that off or you can just access it on Blackboard. I would really recommend just printing it off for this section so you have it available to you. But all the conversion facts that you're going to need are on this sheet. These are the common ones for your industry. Some basic volume conversions, length, mass, area, and a few kind of unusual conversions dealing with power and energy and pressure that show up on topics we're going to work with later in the class. So print that off from Blackboard. But for now, I'm just going to reference those that are on your screen. The problem we were working with wanted to change liters into quarts. So if we look at volume and liquid measurement, right here we have 1 liter is equal to 1.056 quarts. Some of these conversions have kind of a squiggly equals, and that means it's not an exactly right conversion, but it's really close. So 1 liter is 1.056 quarts. Let's use that to answer our question and perform our conversion. Okay, so we're going to have to put liters on the bottom so that they cancel. Liters, make sure that you're writing your units when you write these out. Quarts goes on the top. 1 liter is 1.056 quarts. We just saw that on our conversion sheet. That makes the liters cancel off. And now we'll reach for our calculator. Now this time we have 12. The 1.056 is on the top. That means we're going to multiply that. And then we divide by anything on the bottom, which is just going to be a 1. And so you can divide by 1, but of course that's not going to make any difference. And our result is 12.67, again if we round to the hundredth. In your assignments you'll be told where to round, but when in doubt you can typically round it 2 decimal place. And we now have 12.67 quarts because the liters canceled off. We basically made a trade. We made a trade of liters to quarts. Okay, I want you to take a minute and do this one. An empty radiator weighs 7.5 pounds. How many kilograms is that? Go ahead and write out this conversion process and then resume the video to see what that should look like when you're done. Okay, here we go. So our radiator weighs 7.5 pounds. The abbreviation for pounds is LBS. We're going to put that over 1, and now we need to change pounds into kilograms. So we need a conversion fact. If we take a look at our conversion facts, or if you've printed off the conversion sheet from Blackboard, you can see that under mass, 2.2 pounds is about the same as 1 kilogram. That's the conversion fact that we want. And in fact, if you've printed off your conversion sheet, it's right there on your conversion sheet as well. 2.2 pounds is about 1 kilogram. So we need to put the pounds on the bottom so that they cancel diagonally. We're going to go to kilograms. And we just saw that 1 kilogram is 2.2 pounds. That makes the units of pounds cancel, and we can reach for our calculator. $7.5 is going to be divided by 2.2 since the 2.2 is on the bottom, and we get 3.41 when we round to the hundredth. Those are now kilograms. Now, along with conversion facts that are given on your sheet, there are a lot of conversion facts that you should just know off the top of your head that are really, really common and show up all the time. I want to take a look at 7 of those with you right here. These shouldn't be on your conversion sheet and you shouldn't write them on there. You should just get in the habit of recognizing these and knowing them, and I'll bet you know most of them already. The first one right there, 1 foot is equal to 12 inches. Typical wooden ruler is a foot. It's the same as 12 inches. You don't need that on a conversion sheet to know that. The next one you should recognize is that a yard is 3 feet. A typical yardstick, about waist high or so, can be broken into 3 feet. Handy to know for measuring shop spaces or things that are sold in lengths like chain or hose. A gallon is 4 quarts. Hopefully that one you recognize. Think about a quarter. There's 4 quarters in a dollar, 4 quarts in a gallon. A pound is 16 ounces. Think about lug nuts. A typical lug nut weighs about an ounce. It's going to vary, of course, but a set of 16 lug nuts would then be about 16 ounces. It's going to be about a pound if you hold them all in your hand. A ton is 2,000 pounds. That's a real common one to know. And a small smart car, which I don't think are sold in the United States anymore, but a smart car weighs about 2,000 pounds. And then there's 2 metric facts that you should know. We've already seen some of these. We're going to explore more of them in part 2 of this topic. But a meter is 100 centimeters. And you can just think of the root word centi. There's 100 cents in a dollar, 100 years in a century. There's 100 centimeters in 1 meter. Now that leads to a common error, though, that I want to warn you about. A lot of people think that a meter and a yard are the same thing, but they are not the same length, so be careful of that. A meter stick is a little bit longer than a yard stick. A meter is about 39 3/8 inches, whereas a yardstick is only 36 inches. So this conversion fact is not on your sheet, and it's not one that we'll use very often, but a yard is a little bit shorter. It takes more than 1 yard to make 1 meter. Be careful of that. And the last one I want you to just recognize is one that we've already used in our measurement unit. You need to know that 1 centimeter, which is about the width of a pencil, is 10 of the smaller millimeters, and that's about the thickness of the lead in a wooden pencil. So 10 of the smaller metric millimeters stack up to make 1 centimeter. That one's common to need to know when you're dealing with metric bolt sizes. Sometimes they're given in centimeters, and sometimes metric bolt lengths are given in millimeters, so you should be able to flip back and forth in your head. Okay, let's take a look at a couple more conversions because there's something else I want to show you here. Typical dehumidifier is rated according to how much water it can remove from the air in humid conditions. So this is a 70-pint dehumidifier. How many gallons is that? All right, so let's set this up. We want to convert 70 pints into gallons. So if we set up our conversion fact, we're going to start by putting 70 pints over 1. Now, we'd pull out our conversion sheet and we'd start looking for a conversion fact. And if you look at your conversion sheet, all the conversions we have access to, you won't find one. We don't have access right here of a conversion fact between pints and gallons. Now, it doesn't mean it doesn't exist. It just doesn't mean, it means that it's not handy. So you can use the cancellation process to do this anyway. Here's what we'll do. We know that we can change pints to quarts. And then we know that there's 4 quarts in a gallon. So we're going to use 2 conversion facts here. 2 pints is equal to a quart, and 4 quarts is equal to a gallon. The top one was on your sheet. The bottom one is one of the common facts that you should know that we just explored. We can stack these together like cars and a train in tandem. We can trade in our pints, 2 pints, for 1 quart. That cancels off the pints and gets us to quarts. Now don't multiply that out. We can use our other conversion fact to stack right onto that and say that 4 quarts is 1 gallon. So we're doing a double trade. We trade pints for quarts, and then we immediately trade our quarts for gallons. And now we're ready to multiply across. So if you take your calculator, multiplying across the top, we have 70 times 1 times 1. Of course, that's 70. And then we're going to divide by the bottom. That's divided by 2 and divided by 4. Or we could just divide by 8, their product. But we'll divide by 2 and divide by 4. and that gives us 8.75. The only units that didn't cancel are gallons, and so that's 8.75 gallons. And we're done. The key here is the unit cancellation process. That's what's going to be really valuable later on when we work with compression ratio, where we have a lot of mixed units. Being able to keep track of your units and cancel off the ones that you don't want. The answer is not the most important thing about this process. It's this cancelability, and that's why make sure you're using this process when you do the problems for this topic. Okay, let's take a look at two more examples, and then I'm going to give you a little practice as we wrap this up. A VW Beetle weighs 820 kilograms. How many tons is that? Well, let's figure it out. 820 kilograms will be put over 1. Now we want to get from kilograms to tons. We can't do that in one step. We already saw that 2.2 pounds is 1 kilogram. We can use that fact. And we also know from the common facts that 2,000 pounds is equal to 1 ton. So that's what we need. We'll set up our trades. First, we're going to trade kilograms for pounds. 1 kilogram is 2.2 pounds. That makes the kilograms go away. But we don't want pounds, we want tons. So we're going to trade in 2,000 pounds for 1 ton. That makes the pounds cancel off. We got tons, that's what we want. It didn't cancel. We reach for our calculator. 820. Is that 2.2 going to be multiplied or divided? It's in the top, so we're going to multiply that. And then is the 2,000 going to be multiplied or divided? It's in the bottom, so we're going to divide that. And when we do that, we get 0.90 tons. One more. Engine displacements are one of the things that we'll use this for. Let's convert 350, that's a classic Chevrolet engine, into liters. If you're a General Motors person, you might already know what this is going to turn out to be. 350 cubic inches. How can we get from cubic inches to liters, though? Let's take a look at our conversion sheet. It's not always clear what sequence to use, but here's what we're going to do. We're going to trade cubic inches in for cubic centimeters, also known as cc's. A lot of engines are measured in cc's or cubic centimeters. And then we can trade in cubic centimeters for liters. So we're going to do this in two parts. First, we'll use 16.39 cubic centimeters per cubic inch. That makes the cubic inches cancel. Now we have cubic centimeters. And we're going to use our second conversion fact right here. 1,000 cubic centimeters is equivalent to 1 liter. That cancels off the cubic centimeters. That gets us to liters. That's what we wanted. We're ready for our calculator. 350. 16.39 is on the top, so we'll multiply. 1,000 is on the bottom, so we'll divide that off. And we get 5.74 liters, which of course GM called the 5.7 liter engine for many, many years. Okay, that's it. I'd like to have you do a little bit of practice here. I have two practice problems for you. The first one is there's a bridge up ahead on this interstate, and it says that the clearance, that's a little hard to read, is 10 foot 9 inches. And my question is, how many meters is that? My second question is, we've got a gas generator here that's powered by an 11 horsepower 11 horsepower engine. Convert that into watts to see how many watts that engine could produce. That's on your conversion sheet. Unpause the video and you're ready to see how those look. Okay, here we go. 10 feet 9 inches of clearance. We already established that 10 feet times 12, that's 120 inches, plus our 9 inches. Our clearance could be stated as 129 inches. So let's take 129 inches. If you're not familiar with the notation, 2 tick marks always represents inches, 1 tick mark always represents feet. So 129 inches, how can we get to meters? Well, it's one of the most common facts that's used. 1 inch is 2.54 centimeters. So let's change our inches into centimeters, and then we can go from there to meters. So 1 inch is 2.54 centimeters. That cancels off our inches. And then it's one of the common facts that you should know that 100 centimeters is equal to 1 meter. That trades in centimeters. And then we're ready to calculate that. So you can take your calculator, 129 times 2.54, divide by 100, and you get 3.28 meters. If you didn't get that, make sure that you rewind and watch that process again. Very important process to use. We're going to have you'll be using this a lot later on in the course. Okay, in our last problem, how many watts can this 11 horsepower generator produce? Well, let's just take 11 horsepower and put it over 1. It's kind of an interesting conversion fact between electrical and mechanical power. 1 horsepower is about equal to 746 watts. So we can use that conversion fact to trade our horsepower in for watts. So we'll put horsepower on the bottom since we're trying to cancel those off. 746 watts goes on the top. Capital W is the symbol for watts. Horsepower cancels. And all we need to do on our calculator here is take 11 times 746. No need to divide by 1, that won't change anything. And if you do that, you get 8,206 watts. Now, generators aren't 100% efficient, so it won't actually make 8,206 watts. This generator is actually only rated for 6,000 watts because some of that engine's power goes into noise and heat. Not all of it becomes electricity, but theoretically, it could make 8,206 watts. Okay, that wraps up part 1 of this topic. There's another short part dealing with just the metric system. Make sure to follow up with part 2 of this series. But that wraps up part 1. You now know how to use a conversion fact and turn it into a unit fraction. You can put whatever units you need on the bottom so that they cancel. And make sure that you print off or have easy access to these conversion facts while you're doing the practice problems and the skill checks. These are tough problems if you don't have any conversion facts to work with. Okay, that's it. We'll see you in part 2.